Alright, so let's look at algebra of complex numbers. The algebra of complex numbers has to do with the addition, subtraction, multiplication, and division of complex numbers. Alright, first of all, let's look at the addition of complex numbers. The addition of complex numbers is defined by separately adding real and imaginary parts. Now let's take an example. If z is equal to a plus bi and then y is equal to c plus di, and we are asked to add z and y, how do we solve it? So z plus y is equal to a plus bi and then plus c plus di. So now let's take off the bracket. So we have z plus y is equal to a plus bi and then plus c plus di. Our next task is to take the real part and add it up, and then take the imaginary part and also add it up. So z plus y is equal to, the real part here is a and c. So we have a plus c, and then plus the imaginary part here is bi and di. So we have bi plus di. So z plus y is equal to a plus c and then plus b plus d, and then multiply by I. So this is our final answer. Alright, so let's take another example. If z1 is equal to 3 plus 5i, and then z2 is equal to 2 minus 3i, and we are asked to add z1 and z2. So z1 plus z2 is equal to 3 plus 5i plus 2 minus 3i. So now let's open up the bracket. So z1 plus z2 is equal to 3 plus 5i, and then plus multiplies 2 is plus 2, and then plus multiplies minus 3i, it is minus 3i. So therefore z1 plus z2 is equal to, so our next task is to collect like terms. You add up the real part and add up the imaginary part. So the real part here is 3 and 2. And then for the imaginary part, we have 5i minus 3i. So z1 plus z2 is equal to 3 plus 2 is 5. And then 5 minus 3 is 2. So we have 5 plus 2i. So this is our final answer. Alright, so let's consider the subtraction of complex numbers. Subtraction of complex numbers. If z is equal to a plus bi, and then y is equal to c plus di, and we are asked to subtract y from z, z minus y becomes a plus bi minus c plus di. So z minus y is equal to, we open up the brackets, so we have a plus bi, and then minus multiplies c, so we have minus c, and then minus multiplies positive di, so we have minus di. So z minus y is equal to, you take the like terms, so we have a minus c, and then plus bi minus di. So z minus y is equal to a minus c plus b minus d multiply I. So this is our final answer. Alright, so let's take another example, still on subtraction of complex numbers. If z1 is equal to 3 plus 5i, and z2 is equal to 2 minus 3i, and we are asked to subtract z2 from z1. So therefore, z1 minus z2 is equal to 3 plus 5i minus 2 minus 3i. So z1 minus z2 is equal to, now let's open up the bracket. So we have 3 plus 5i, alright, minus multiplies 2, it gives us minus 2, and then minus multiplies negative 3i, it gives us positive 3i. Alright, our next task is to collect like terms. So z1 minus z2 is equal to 3 minus 2, and then plus 5i plus 3i. So z1 minus z2 is equal to 3 minus 2 is 1, and then plus 5i plus 3i is 8i. So this is our final answer. Alright, so let's take the third example on subtraction of complex numbers. It says solve 7i minus 4 plus 5i. So our first task here is to open up the bracket. Open the bracket. So if we open up the bracket, we will have 7i minus multiplies 4. It gives us minus 4. And then minus multiplies positive 5i. It gives us minus 5i. Alright, so our next task is to collect like terms. So if we collect like terms, we will have 7i minus 5i and then minus 4. 7 minus 5 is 2, so we have 2i minus 4. Now let's rearrange this. So instead of 2i minus 4, we write minus 4 plus 2i. So this is our final answer.